Alright, so far everything we've done, we've been able to get a common base, either by changing something to rewrite it as a power, or they were already given to us, or we had a log set equal to a log and they both had the same base. But that's not always the case. There's going to come a time that there's not an integer power that will let me do that. You've noticed probably already this log button on your calculator. But to do logarithms, we've been going through math, log base, right? Because we've been changing the base every time. The log button on your calculator is what's called a common log. You'll see sometimes, the log of 67. The implied base there is a 10. It's kind of like when we take the square root of 9. We don't write the 2 here, it's just that square root is so common, we quit writing it down a long time ago, and now it's implied that when you see the radical, if there's nothing written in the index, that it's a 2. Same thing with logs. I can write log, base, anything I want, and work with it, but if I just see log of a number, then the assumption is that we're talking common logs and we're using 10. So when I see log 50, that's really asking what power of 10 gives me 50? Well, for that one, I can go through the whole log base process and do the 50 and get an answer, or I can just type log of 50 and I'm going to get the same thing. It's pre-programmed with that common base of 10. When I get that, I want to keep approximately 4 decimal places. In this one, I've got that 7 in the fifth, so I'm going to keep them all. 1.69897. And I check that by saying, is 10 to the 1.69897 equal to 50? So 10 raised to the 1.69897. And again, it's a really, really close approximation, so we're good. Okay. So here's where this is helpful. If I remember that 243 is 3 to the 5th, I can rewrite this. 3 to the x is greater than 3 to the 5th, and I can solve x greater than 5. No big deal. But if I didn't remember that, okay, or maybe I missed it when I was going through my chart or when I was trying different values and I couldn't come up with a power of 3 to get 243. So then what we're going to do is, because logs and exponents are inverses, we're going to start with 3 to the x greater than 243. We're going to take the logarithm of both sides. So now it says log of 3 raised to the x is greater than the log of 243. Because of my power property, I know that this x is actually going to turn into multiplication. And then I'm going to divide by the log of 3, divide by the log of 3. And I know that x is greater than, when we get ready to type this, about the only thing you have to worry about is parentheses. Log 243, close it, divided by log of 3. And I still get that x should be greater than 5. You can set it up as a fraction so that it looks exactly like it does on your paper. There's nothing that says you can't put logs in fractions. And it's not going to change the calculation or the way you get your answer at all. Okay? So as long as x is greater than 5, same thing. Okay? Just because we add more terms to the exponent does not change the way we work the problem. This is still in parentheses. I'm still going to take the log of both sides. And my power is going to come out front as multiplication. 2x plus 1 times the log of 3 equals the log of 12. I'm still going to divide the log of 3. And now I get 2x plus 1 is equal to, when I do log of 12 divided by log of 3, I get this crazy decimal. Here's where care with carrying the extra places will make a difference. Okay? 2 point, and at this point it becomes an approximation, 2.2616. And then we just keep solving. Minus 1, minus 1. 2x is approximately 1.2616 divided by 2. X is approximately minus 1 divided by 2. 0.6309. Okay. Let's go back and check it to make sure. So we're going to write 3 to the 2 times 0.6309 and see what that equals. 3 raised to the 2 times 0.6309. Okay. And we got 4, basically, right? Well, because we left the plus 1 out of there. So here's something that I need you to start getting in the habit of. If you arrow back up in your calculator, you don't have to retype the whole thing. You just go get it. Okay? Plus 1. Is that it? Did we just check wrong? Well, I got 11.999. I was hoping for 12, so we're good. X is approximately 6309. Okay. Now, notice in these 2 steps how we ended up dividing logs anyway. Okay. I can do that if I just need to rearrange. Sometimes maybe it would be nice to have them in common logs. Log base 8 of 15. So I've got the log base feature on my calculator. I can do that. If I'm using one that doesn't have it, or I don't have access to anything other than just a log button, I'm going to use this change of base formula, which just says, if we're real careful, see the n stayed in the numerator and then the base stayed in the base. I can change it to anything I want. Commonly we use this so that we can get common logs. So I'm going to take log base 8 of 15. Using common logs, I'm going to use the log of 15 over the log of 8. Here's our conversion. And then when I type that, log of 15 divided by log of 8, I get 1.3023. Which, if we compare that using our old log base approach, right? 8, 15. I still get 1.3023. Okay? So either option works. We have the luxury of calculators that do this now, but if you're using a different one or an older one, or you don't, the thing on your phone where you can only do common logs, then this change of base is how you get access to that.